when you browse on a on any platform, basically in the Google servers or Google Chrome or any browser, the first thing they will be looking into is the location, because let us be interactive, or let it be from my side only.
For the time being, you continue, sir. For the time being, you continue. We will, our people will ask a question later on, and we will try to present it. I am sending to Joy for a better that one presenting and all things. And I already received the presentation. You say, sir, you please continue.
Okay. So this location-based trend is going, and the next future in I think the 5 to 10 years. If for to say some examples in the field of health, any public health or health in specific, you can find that all the aspects of a person is being recorded with the location specific information. If you use a health app for walking, they are tracking your location. Why they are tracking your location? Because all the health aspects is location based, and it has got links to the location. So you are being tracked from morning to evening, or the 24 hours by 7. So if you are on an internet, because now as everybody is having mobiles, especially smartphones, and you are always on internet, and you are being tracked 24 by 7. So wherever you are going, what are you doing, what is your health systems, and now the health apps are coming up. Even in the coming very 4 to 5 years time, you will be finding thousands of apps in your sensors in your mobile, and it may not be called mobile, but the growth of the technology is so fast that presently you may have 10 to 20 sensors in your mobile, but into 5 to 10 years you will be having thousands of sensors, and your mobile will be having powers of present servers. So you will be sending information from your mobiles to servers or the server clouds, where they will be collecting all your location information. All the location informations will be processed in real time. And to say an example, if you are walking or if you are riding, it is possible that an ambulance that come and stand in front of you and tell you that you will have to get into the ambulance because you will be having an attack in 1 or 2 hours time. So that will be the type of location specific technology growth and services, and we will be dealing with the location based services in today's classes, because GIS is now heading towards location based services, and the location based services have already grown into a level that you have got autonomous vehicles, you have got services. Even if you browse on a browser for any of your needs, that just to buy a shirt, just to buy a shoe, just to buy a ladies item, anything that you search, immediately you can find an advertisement on the right side of your browser about the thing that you are searching, and the advertisement will be locally specific, not from other part of the country or other part of the world. That's because they can service things with the help of location specific information. So business advertisements, and it's very targeted advertisements that are going on. You will be getting specific interest based advertisements in your mobiles or in your browser. That's because you are always, everybody is on the Facebook, lot of apps everybody is using, socially relevant apps everybody is using. So social media, they will be collecting all your location information, all the aspects of your location. And this location is, as I think everybody knows what is a location. Being engineers, everybody will be knowing, and it's a latitude, longitude, or position on the Earth. So that position is being recorded, and the characteristics of you or your taste or whatever things that you are interested, the taste of your food type, taste of your color, taste of your friend circle, everything is being monitored. That's why, because in an annual survey, this Facebook are giving you your reviews, the activity review for the year. I think everybody will be happy to see that Facebook and all these social medias are giving you annual reviews. Annual reviews is the core activity that you have done in that year, because you have been tracked for that year, and they have analyzed things in artificial intelligence and the core things that is being given back to you, and they know you better than you, and the world knows you better than you. So they will give you targeted advertisement based on your taste and based on all your even if your thumbs up or likes is creating information for the Google or the cloud to understand your characteristic, understand your taste, so that you will get targeted advertisements based on that. The presentation is ready, or
it is also some problem, sir. I will you proceed. You will put up.
Okay. So these things, basically, the geospatial technology, as I have already told, comprises of 3 types of technologies, which is remote sensing, GPS, and GIS. Remote sensing is basically a technology which is used to acquire information, spatial information. So there is a difference between information and spatial information. Now, normally, I think there is a sound disturbance. Yeah, it's coming up. Remote sensing and GPS are technologies that is used to acquire information, spatial information. And simply, if you tell an information in an information system that you handles mostly are tabular informations, which doesn't have any location specific tags attached to it. So a spatial information is an information that contains the location information along with it. So the data that is collected, the remote sensing and GPS collects information of the earth, basically of the earth, with respect to its location. So that's why it's called spatial data. Spatial data, and these 2 technologies, remote sensing is a technology that collects information with the help of satellites, aircrafts, balloons, helicopters, or from drones. Now as you everybody knows, you can see, even if in a marriage you can find drones. So based on these technologies, we can collect information, and mostly we collect information with the help of sensors in the case of remote sensing. And as for aerial surveys, we use cameras. That is, we use cameras to get aerial photographs. So that will not be from much height. It's a flying height of an aircraft or an aerial photograph. You will be getting information with the help of cameras. But satellites and other aspects of the remote sensing collects information with the help of sensors. Sensors gives you images, and cameras give you photographs. So basically, these 2 technologies, remote sensing is a technology that gives spatial information with the help of sensors and cameras. But in the case of GPS gives you location information. Location information, speed or velocity, or the position, velocity, and direction. All these information will be provided with the help of GPS. GPS is Global Positioning System, and the Global Positioning System comprises of 24 satellites, it's across the globe, and you will be having the globe covered by the 24 satellites, and GPS is an American constellation of navigational satellites. And since they were the first country to provide navigational satellite information to the country, to the world, or for the citizen, that name GPS was considered synonym for the navigation systems. India is already having a navigation system which is called a NAVIC, but it's a regional navigation system. It is called it is covering all these India and the SAARC areas alone. So we don't have an entire global navigational system, but India is having a navigation system for our purpose, and it may grow for the global level in the near future. And a lot of other countries are also having these global navigation systems, like China, Russia, a lot of European Union. Everybody is having their own navigation systems. And now, as the technology grows, since the citizen, this high-end technology is provided, the GPS technology is provided. What they have done is, since all these technologies have originated for the military purpose. Once the military purpose, as the military started using it, the potential of this technology for the natural resources or the resource evaluation and the citizen utility came up, and the technology gradually came in for the citizens' purpose or for the scientific purpose. So this technology, as the GPS, when it came for the citizen, they are always afraid of the accuracy levels, because once the citizen, if it is open to the people, there is a problem that it can be used for good and bad activities. So when you use it for bad activities like terrorism and other things, that will create some problems. So that's why what they have done is they have entered and knowingly entered some error to the data that has been provided free to the citizen. So the GPS, that's why, is having inherent errors. And for the military purpose, it will be accurate. The data sent to the military activities and their receivers will have better accuracy compared to citizen service. So that inherent errors need to be corrected with the help of technologies like differential GPS. So I think
സാർ എക്സ്ക്യൂസ് മീ, ഇപ്പൊ പ്രസന്റേഷൻ ഇതിലുണ്ട്, ഏത് സ്ലൈഡാണ് വെക്കേണ്ടതെന്ന് പറഞ്ഞാല് സാർ അവിടെ ഓപ്പൺ ചെയ്തിട്ട് കമ്പ്യൂട്ടറിൽ ഓപ്പൺ ചെയ്ത് പറഞ്ഞു കഴിഞ്ഞാൽ അനുസരിച്ചൊരു സ്ലൈഡ് വെക്കാം. ഇപ്പൊ ആദ്യം നമ്മൾ ആദ്യത്തെ ആൻ ഓവർവ്യൂ സ്പെഷ്യൽ റെഫറൻസ് ടു LBS എന്നുള്ളതാണ് ഉള്ളത്. ഏത് സൈഡിലേക്കാണ് പോകേണ്ടത്?
അത് സ്റ്റാർട്ട് ചെയ്തോ, ഞാൻ പറയാം. ഞാൻ നെക്സ്റ്റ് പറയുമ്പോൾ മാറ്റിയാൽ മതി.
ഓക്കെ 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 ഓക്കെ.
So as we are telling the GPS, we are using now the digital technology with the help of differential GPS. That is a differential GPS is a technology which helps to improve the accuracy up to the sub-meter level, even centimeter level accuracies can be achieved with the help of more observation timings and all other things. So that I'm not going deep into the GPS technologies, because we are now dealing with the GIS, but the location is the buzzword, and the location information is being given by the GPS in your mobiles, and GPS or the navigation facilities in your mobile, and the satellite, different types of satellites. Even the NAVIC is now coming into the mobile GPS, so which will improve the accuracy of the mobile GPS also. So this location, as it is the buzzword, is highly useful, and the location specific, and the LBS is called location based services, and GIS is used for location based services. And I will say what the LBS is and what is GIS is also in general in this class, because it's an MTech topic, and you will not be able to do it in 1 hour or so. I will just have an overview. I will just say what are things that can be done, what are the softwares that are available, and what are the techniques that is used for some applications. And I thought that I'll be showing you also some application location based services or mobile apps that we have developed, and the results of the mobile apps applications from my side, from my computers. But I have some issue with my camera, so that's why I apologize for my issues. So next slide. Yeah, our topic will be, today's will be, what is LBS, what is GIS, and GIS has got 3 different components called desktop GIS, web GIS, and mobile GIS. So, which comprises the entire geographic information system suite of things. Desktop GIS is the LBS is the location-based services, and the location-based services, as I was giving an introduction, it's basically about all your location. An autonomous car senses its location, senses the surrounding object's location, and moves along the road. And it senses the location of the car itself or the vehicle itself, and the location of the surrounding objects while on the move. So that's called real-time analytics, real-time data analytics, and it's huge information that need to be analyzed. Huge information in the sense, it's called now, I think everybody might have heard of big data. Big data, and normally there is a difference between big data and database. Big database and the database can be differentiated basically by database is a structured, organized information. It can be told information. There is a difference between data and information, because information is the processed data. So data, when it is structured, it's called a database, and big data is an unstructured data. Unstructured data in the sense it can handle these big data came because everybody is using social media like Facebook, all these Twitter and all other things. You are sending in information to the cloud. You are sending text, you are sending photos, you are sending videos, you are sending documents, you are sending voice. Everything is coming into the database, and they need to store the database, they need to analyze the database, they need to query the database, they need to retrieve information from the database. So a normal structured database won't work for the case of this kind of huge information that is coming up. So that requirement caused the development of big database. So the big database was generated for this kind of purpose, like Facebook have developed Cassandra, Google has developed Bigtable, and these are all examples of big database. And you will have MongoDB coming up where it's in a huge way in open source. Cassandra is also given open source by Facebook. Bigtable is not in open mode, but a lot of open source big database is already there. And LBS is basically with the help of this big database on the back end. Location-based services, I think everybody will be using the navigation in the car or in the mobile. The navigation is again real-time analytics, and it's a location-based service, because each moment your data is being collected, analyzed, and while you are moving, your track is being shown and where you are standing, and at the real time your data is being processed. And when you reach a position, they are telling you to move right, you go down, there will be a congestion ahead. How did they know that there is a congestion in front of you? So they will be asking Google Sound will be, I think, a lady talking with you on the Google will tell you that there is congestion ahead. It's better you turn right and go to the in a different way. And it's 14 minutes, 14 minute faster or 14 minutes slower than what you think. All these directions are being given with the help of real-time analytics. That's location-based services with the help of GPS. Since everybody is using GPS and since there is a algorithms running and a real time and there is a big data analytics which is run with the help of machine learning and artificial intelligence, there will be knowing that if some amount of vehicle is being stuck for some time, more than some 2 minutes, 3 minutes, they will consider it as a jam. So that's why with the help of that kind of data analytics, they are telling you to move off from the present road to the another road and take a diversion and get linked to the main road in a different position. So that's how the LBS works. We are using LBS, we are using GIS, we are using GPS, we are using geospatial technology, but we don't know the names. Everybody, because the technology is so proactive, technology comes very fast to each and everyone, because that's why now everything is being coming up as smart. You tell smartphone because it supports you, it's intelligent, it can you can ask the phone your information and it gives you back the information. That's why it's called smart. So everything is now coming up: smartphone, smart man, smart family, smart city, smart house, and smart kitchen. That's the next level of things coming up. Your kitchen itself will become smart, because when you send SMS or when you send a voice message to your kitchen before starting from your office, you will get things hot in your kitchen when you reach home. And when you reach home, in front of your gate will open and it's already there. The technology is already there. And gates will open because the sensor knows that you reached. And the doors will be open. Everything will be automatic. Alexa is running things automatic by your voice message when you are in range. So everything is location-based services. I think I've conveyed what is location-based service. And next slide. Thank you. So these location-based services, or the GPS, is the technology that tells you where am I on the globe, and that question helped to create these kind of technologies, because people used to get lost in the place of the earth. While you move around, you get lost. And for a long time we used maps. Earlier they used to see the position of the sun, direction of light, direction of shadows, length of shadows. All these things were used to identify their position. Later, when we developed maps, we used to navigate with the help of maps. Now the technology has come in such a way that it gives you the location and you can ask where am I, and the technology and what are the things nearby. That's the biggest thing that's happening now. Which is the hotels nearby me, which is the petrol pump near me, which is the ATM near me. All these things can be queried and you get information. Who is the plumber near me, who is the electrician near me, who is the service station near me. All these things are queried with the help of location-based services, because whenever you are in a position, it encircles you, a 1 kilometer circle, and asks you and gets you information. It fetches you information about what the question you are raising, about your position, hospital, location of hotels, or anything. So you can ask the nearest pump house, valve, overhead tank, etc. Because when you have the database with you, or when you have the database in the server, which is being analyzed and which is being serviced to you to when your people around, which is the type of pipeline under the road, all these things can be queried and you can get information once the database is processed and it's being analyzed and it's set for the queries. So all these things can be done, and that is location-based services. Next slide. Yeah, it works on a range of applications. Basically, it has a operator-based services, it can track where you are moving here and there, or what are the on which road you have moved, and how many times you have moved. All these things can be tracked. Operator-based services can be given. It can analyze who are the operators moving, and what are the machines working, which are the pumps working. Operator-based services. Assistance, it can give assistance to the field people. What's the type and what's the dia of the pipe under the road, where the valve is, and which valve should be closed for in order if you have a leak at a particular road. All these things can be done. You can monitor the activities. You monitor the work, who all are on the ground now, which are the areas where the damages are being repaired, and which are the pipe which is getting damaged regularly. All these informations can be monitored. Monitoring is very efficient with the help of GIS. I should have shown some examples of monitoring and tracking with the help of our mobile apps for road tracking, monitoring of wells, surveying of wells, and survey of sanitation survey of the rivers, which are the houses that doesn't have defecation facilities, and all these things. Lot of information was collected, and lot of information is analyzed, and it's being served across the web. And the technology has grown in such a way that anybody can access information with the help of their mobile, and that information is being given in fingertips. So once the database is being built, structured, and fed into the server or the database, you can query it, analyze it, and get information for all your ease of life, ease of doing, and ease of active working. Next. So you can have LPS with the help of all these mobile devices. It has got your navigation system from your vehicle. You can have your iPods, you can have your laptop, you can use your PDAs, you can use your mobile phones, you can use GPS handheld instruments, anything, any moving instruments can be used now for LBS, location-based services. You need to have a GPS fitted instrument, and which a display that can show you information, and that's enough to run location-based services, because the technology has gone proactive, and it can reach people at any position, anywhere in the globe, except some difficulties where there is reach of signals. Otherwise, LBS is available everywhere, and the technology is growing, and database is growing, and it's growing in multitude of dimensions, not in a progressive dimension. It's growing in a polynomial direction. Next. And it has got definitions which is academic of interest, may not be of interest now, because I've already explained. There are two different explanations. It's from mobile network, mobile devices, you are accessing information. Next. Yeah. And LBS has an intersection of three technologies. Basically, it's an intersection of technologies called the GIS, or Geographic Information System, with the spatial database, and it's an integration of mobile devices. That's the front end or the user interface, and the GIS is the technology that runs behind. And you need to have your backbone of internet. All these three technologies are there. You are ripe enough to use the location-based services. So these three technologies, when integrated, will give you web GIS, mobile GIS, and your mobile internet connection will integrated in the form of LBS. So web GIS, I earlier in the earlier slide I've told there is three segments in GIS, or Geographic Information System, and the first segment is desktop GIS, and which is, as all of you know, in your computer you can load the GIS, and the Geographic Information System software works in the computer, and you can use it in the computer alone, and their license is for one computer, and you can't publish it, and you can't give it to the your friend, or your people are on the ground. They may not be able to access because it's restricted to your desktop device. That's desktop GIS, but its capabilities are immense, and its analyzing power is immense. And the web GIS is the next phase, because the GIS as a software is costly, proprietary mode, very costly, since it has got its own capabilities, high-end capabilities in a costly service area. But there are open source softwares also which are coming up with its technology, and it's trying to cope up with the upcoming technologies day in and day after, and it's coming up. And for a beginner, an open source GIS will be more than enough. Even a beginner may not be able to use all the technology, all the capabilities of an open source GIS itself. So since these restrictions are there in the case of desktop GIS, the technology has grown since it is costly, and a user in 90% of the case may not need all these capabilities. 90% of the user may require only 10% of the capabilities, and there is no need that all the users should buy these costly software to get their things done. So the thing has now come up as WebGIS. You can access GIS on a browser. You don't need to install software. You don't need to have a knowledge of GIS. You don't need to know what is a polygon, what is a point, what is raster, what is vector. I will tell something about that later. WebGIS helps you access GIS data, access spatial data, and get your information for anybody without the knowledge of all these things. As we are using navigation systems without the knowledge that we are using geospatial technology, and we are using location-based services, location-based targeted advertisements, and our life is surrounded by location-based services, which we don't know it's a geospatial technology or the technology advancement that is happening. So WebGIS is a part of that, and you can access in the web browser all the information that is available, and all the analytics capabilities, not the 100% capabilities, but the requirement 10% is available. You can just click on buttons and you can get information what you need. To say an example, if you want to identify a particular area network of your pipelines, to close a valve, or if you give a query, if I close this valve, which are the pipes going to get affected, or which is the area that the water supply will be affected, and it can show you if you close the pipe, close the valve, it shows you these are the pipelines that's getting affected. So that query is your need. You don't need to know much of GIS or all the GIS aspects, all the capabilities of GIS. For your job, you need these things. You just click on select the valve, ask the question which are the area that is being affected, and you get the information. You get the pipelines, you get the supply areas, you get the houses which are being affected. All these informations will be provided in the help of WebGIS. But coming to the location-based services, as we are telling now, this WebGIS still is not effective, since it requires a browser, it requires your mobile screens are very small. So in the mobile screens, you may not be able to visualize, or you may not be able to completely appreciate the WebGIS activities. So that's why the mobile GIS platform came. The mobile GIS, you get informations and you get location-based services based on in the browser. And if you use your browser, all these, since if you carry and travel with a laptop, things are okay, and it's you will not have Wi-Fi connections, but you may have your mobile connected again to that. And since the Wi-Fi links are not available everywhere, your browser connections or the WebGIS part of the world stops there. So that's how the mobile part of the world came, since the mobile internet is keeping things so healthy that all these location-based services became possible. And the technology that needs to be grown, that so that the analytics and information service can be more proactive, more productive, more useful when your backbone is strong, and the backbone is internet. And that's why things are growing from generations to generation. Now we are on the verge of 5G. We are growing from 4th generation to the 5th generation, and 5th generation may not be also sufficient, because the technology is growing, the data is growing exponentially, and this exponential growth of data and the exponential development of technology uh, can't be stopped, because the internet technology is to grow with that pace, and that technology is yet.
Hello.
Am I audible?
Yes, sir.
Yeah, next slide, next slide, please. Yeah. Now let us see what is GIS. A Geographic Information System is a software that handles spatial data. That's the crush of it, or the crunch of it. Spatial data, as I've told, is a data that has got location information, where it belongs, and the data belongs to a location. So that information is called as spatial data. It's an information system. Everybody might have used other information systems while you are accessing a railway network for booking. It's an information system. And bank, while you are accessing for money transaction, it's another information system. But a geographic information system is an information system which handles spatial data, the data collected with the help of remote sensing and GPS. So it will have its location information, and it's an information system comprising of hardware, software, data, methods, persons, storage, updation, manipulation, analyzing capabilities, and display of information. And the GIS comprises of all these things. Next slide. I think we are a bit slow. Yeah, it gives us geodata services and geoprocessing services. We had been discussing about LBS, all these things. Next. And the key features comprises of computer database, digital maps, GPS receiver, and satellite images obtained from satellite. It comprises all these things. We can generate maps from the satellite images, and with the help of GPS, it fixes the location. And we need to build databases, digital databases, which are intelligent. If you give an ask, if you ask, especially in the case of an example of navigation, the database itself is intelligent. It knows which is the road that is moving right and which is the road that moving left. So the database itself is intelligent, and making an intelligence database is the capability of GIS. And it can integrate different sets of data. That is, it can integrate your pipeline with your pump houses, with your valves, with your overhead tanks, and all these layers can be integrated to a common database so that you can query as I've told earlier, when we close one valve, which are the pipes going to be get affected? So that's integration capability is there in the GIS. Next. So it has got some basic fundas which may not be of much use in the inaugural session. But next, these are the things that comes up. Projection is the technology, because we are working on Earth. We are collecting information from Earth, and it's from the sky, and you are collecting information on a 3D object, and you want to work it in a 2D phase. That's why we need to have projection. We need to convert a 3D information to 2D for your analytics, for your measurements. All these things you need to convert from 3D to 2D. So that's the algorithms, mathematical algorithms working, and it will give some kind of errors. And without error, we may not be able to convert a 3D to 2D, and there will be errors. And I'm not going deep into that. And there is a capability of information retrieval. We have been discussing. All these services are based on information retrieved from the database, analyzed and retrieved. Data output. You get information that you are on this part of the world, in this location, and you'll have to move right. And you get information as an output. Next. And as I've told, you can overlay, integrate. Next. Yeah, you can use modeling. You can use topological modeling. You can build models. You can build models of the surface of the Earth. You can build 3D models. You can elevation while you are laying your pipe, which is the elevation, which is the slope, which direction the slope is, which is the height variation. All these things can be built in with the help of 3D models, which is called digital elevation models. And that there are different types of data in GIS is being handled. The GIS softwares handles basically two different type of data, and one is called the raster data. Raster data, I think everybody knows. Everybody might have seen. I think everybody might have taken digital photographs, and you might have zoomed your own digital photograph and might have seen square things. I think everybody might have seen, and it's called a pixel. And a pixel-based data is called a raster data. So raster data collects information with the help of pixels or grids. It has raster data will have information within a grid. It gives suppose the satellite collects information of the Earth. It collects information in grids. Each grid will be covering a particular area on the ground, and it gives a color or a range of range of color ranging from 0 to 255. It's an 8-bit data. It will be one value between 0 to 255. So that's called raster data, and it consists of grid cells, and it has got huge data volumes. So moving it across web and mobile, it's a huge thing. That's why I was telling that we need to have a good internet backbone, and that internet technology should grow very far, so that these data, this heavy information can be transmitted all across or to all mobiles and get information from the mobiles. And some raster formats are GeoTIFF, grid, ASCII grid, ArcInfo grid, ECW, IMG, all these formats. I think everybody might be knowing GeoTIFF formats, TIFF formats, everybody might be seeing JPEGs, TIFFs, all these things are in raster format. Next. And the other format is vector data. Vector data is representing Earth in the form of point, line, and polygon. Any feature on the Earth's surface will be represented as a point. In the case of assets of KWA, you can take a position of a valve as a point. And you can take all your pipelines as lines. And you can take your pump house or overhead tanks as polygons. So anything and everything on the Earth's surface can be represented as point, line, and polygon. And that kind of database is called vector database. So you will have vector database handling softwares and raster database handling softwares. And now two different types of softwares generated earlier. Now things getting merged down. All the softwares are now capable of handling vector and raster data. Most of the advanced softwares are now capable of handling vector and raster data. So in the case of vector data, data volume is less, and I think everybody might be heard of shape files, map info tab, NTF, Tiger. All these are GIS files, GIS database files. So vector data and raster data are the two main different types of databases that is available. Next. So you can we have covered this area, I think. Next. Yeah, it's moving from the desktop system to the distributed system. I think everybody is now aware of what is a distributed computing or distributed aspects of computation. That's a technology side growing because of the requirement growth. Because when the server side technology came up, mostly it's concentrated on the server itself. So all the analytics, this web GIS and all other GIS, when it came to the web, from the server, we used to do all the analysis and give the information to the front end. So that was the earlier system, but now the Google and all other technologies has grown in such a way that they have now distributed the servers across the globe, cloud platforms across the globe. And based on the location again, sorry, based on the location again, they use servers at that different locations. They get information from different servers, analysis done on a different server, and information is served at a different location. That's called distributed systems. And now the OpenGIS concept is coming up. Since this technology is quite data intensive, quite expertise intensive, quite study intensive, it's very difficult that it should have penetrated to the citizens. But as the technology has grown and the services has been built up from this technology and database, it has reached everyone with the help of mobile. That's why we are telling that mobile GIS and open GIS, open data service. Earlier, this location data were restricted, hugely restricted, and now it's getting open and open. And there is Open Geospatial Consortium called OGC, which set up standards of utilizing spatial data on an open format. Next. So desktop GIS, if you go inside, it's as I've told, it's a real world on a computer. You can see the world, you can reproduce the world or the surface, Earth's surface on a computer, and it's limited to that computer alone. Only the person uses the computer can access, others cannot access, others cannot use the huge potential of the data. So it has got a huge capacity because a lot of analytical capabilities there, lot of you can create a lot of information, but it cannot be supplied to the user on the field. That's why desktop GIS has moved, and it's costly also. That software, the desktop softwares are quite costly, which everybody doesn't need. Next. And there are a lot of proprietary GIS softwares. Next. And the one is ArcGIS Desktop by ESRI, Envision by Autodesk, MapInfo Professional. These are all proprietary softwares. And free and open softwares that you can use are Grass GIS, Quantum GIS. So I think we might have downloaded Quantum GIS, which is a quite advanced one, and beginner more than enough. And you have got a lot of applications, and you have a lot of capabilities, and Quantum is growing, and Quantum itself is integrating Grass and other softwares along with it. So if you download Quantum alone, you will get Grass also. Next. And ArcGIS has got, these are all the old versions of ArcReader, ArcView, ArcEditor, and ArcInfo. suite of things. Now they have got into ArcMap. ArcMap comprises all the analytical capabilities. Next, ArcReader, it can only show you things, visualization. Next, ArcView can have a little analysis capabilities. It can manage and create some geographic information. Next, ArcEditor has got the capability to edit data, analyze, and edit, and it has got capabilities of analysis also. Next, and ArcInfo is the more complete suite, which has got all the facilities of ArcEditor, ArcView, and ArcReader. It can analyze spatial analysis, extensive data manipulation, and high-end cartography tools are there. You can create maps, you can build, analyze, you can query information, you can a lot of informations can be, you can manipulate data also. Next, Envision is from Autodesk. Autodesk is the software which built, AutoCAD software. AutoCAD is being built by the Autodesk, and that it's an integration of AutoCAD and GIS platform. It has got its own calculating and analyzing capabilities. Next, and MapInfo is again a fully featured desktop geospatial solution, which is capable of analyzing vector information. For raster, you need to have a plugin called Vertical Mapper. And since all these plugins together, all these softwares are now capable of handling raster and vector information. Next, GRASS is the geographic resource analysis support system, and it supports various platforms. Windows and Linux and all other platforms support both raster and vector formats. Next, its functionalities, as I've told, geospatial data management and analysis, image processing, graphic maps production, spatial modeling, and visualization. Next, this is the Quantum GIS, which you might have downloaded, and it runs in Linux, Unix, Mac OS, and Windows, and it can handle all the data formats: vector, raster, database formats, and GRASS layers also. GRASS is integrated, and it has got a lot of plugins. Which helps us to extendable functionalities. You can add on plugins and use all the other capabilities. Next, and they have got in the case of application, the location-based services limited to desktop PC and cannot access remotely, and need remote access to GIS because LBS needs access from everywhere and anywhere, transfer information between user and GIS. So next, WebGIS. WebGIS we have already discussed. It's a geographic information system distributed across, and you can access with the help of a browser. And World Wide Web www address, you get the information. I might have shown some examples, but sorry that it didn't happen today. Maybe another day. Disseminate geospatial data and processing tools. It can be disseminated to your to the people across the globe. Anywhere from the globe, you can access. Possible to process geo-related information with no location restrictions. Next. And it's a client-server architecture and distributed architecture. It works in two different. I've already explained these two. Next. And client geoprocessing, server side, client side tasks are not less. Client side will be very less, and most of the processing will be done at the client at the server side. So typical three-tier architecture. Next, it has got a presentation tier, application tier, and the storage tier. All these tier and the storage tier handles the database geospatial. As I've told, a lot of geospatial database structures will be there, and models and process will be run in between as an application tier, and it presents to the user in a web browser. Next. And the architecture will be somewhat like this, and you will have a GIS database and software from where internet map server will be working with the sent to the web server, and from web servers to the browser or to the client. Next. Yeah, there are thin clients and thick clients. It depends on the capabilities of the client. If the client is capable and having more better processing facilities, you will have thick client, and thin client will have less processing facilities and less capable front-end solutions. Next. And distributed architecture we have already discussed. You'll have multiple servers, so multiple access, multiple data collected from different servers, processed at a different server, and supplied to a different end. So geodata anywhere and geoprocessing anywhere model is distributed, and the present model is of all these applications, location-based services are distributed architecture. Next. Internet map service softwares are now processing all these service from the servers and supplying it to the browsers. Interact with the web browser and spatial database. Next. Yeah, it's again web service. Again, there are proprietary and open source softwares are there, and ArcGIS has got its enterprise version. ArcGIS suite of server suite, so it helps you load database in your server and access it from anywhere and analyze it from anywhere. All these things can be done with the help of ArcGIS Enterprise. Advertisements, the Advertisements has got the same facilities. That's from Hexagon Systems. ArcGIS is from a ESRI. These are the I'm Bentley is always there. A lot of softwares are there. I've just the most popular ones I've written. That's all. And it's not that I am talking for them. It's just for an inaugural or an introductory speech, so that people may know some of the proprietary softwares. That's all. Force software or the open source softwares are the Minnesota Map Server, OpenGIS Multiviewer, GIS Viewer, and Jio Server. Jio Server is the advanced now servers that is in the open source, which is helping us to publish information very fast. Next. So ArcGIS Enterprise, I'm not going detail into this because it consists of ArcGIS Server, ArcGIS Enterprise Portal, ArcGIS Data Store, ArcGIS Web Adapter. All these things. Server helps to powers mapping, analysis, and all other things. And Portal is the central hub where create, share, manage maps and apps. And the Data Store helps to host information and process and supply. And Web Adapter interlaces the Data Store and the Portal, so that the supply happens and the analytical results receives us. Next. Advertisements is same. They've got a different format of Luciad portfolio, producer suite, provider suite, and platform suite. All these integrated provides all information and capable of. They are more OGS compliant. Even ArcGIS suite also is OGS compliant, but Apollo has got more of OGS compliant applications like WPS, WMS, WFS, WCS. All these are web service standards provided by the OGC or Open Geospatial Consortium. Next. And Minnesota Map Server, it's an open server which anybody can use, download, and implement. It's a web mapping tool, but you need to know a lot of coding and all other things when you use open source, and you'll have less support. These are the problems in the open source area. You need to have your own strength on the backend to build applications on the open source. Whatever I wanted to show was on open source, but sorry, we will be doing it next. Next, it's Minnesota Map Server architecture. It uses Apache Server, Map Server, CGI, map files, geographic data at the server side, client side, web browser, and gets interlinked with the Jio Server like Map Server. Next. And that's the structure where the map files and map server CGI supply interacts in between map files on the database, and it links to the web server, and from the web server people access and the browser. Next. Yeah, there are a lot of advantages. No dedicated hardware required because you only need to have a browser. There is no other things required. Once the things are stored and built and stored in the server, and you only need a browser to get fetch information for your decision support. Next. And GIS Viewer also is a University of California product, which can be used again for the same purpose. Next. Jio Server, as I told, is an open source server for sharing geospatial data, which is being used. We use Jio Server at our center, and with the help of Jio Server, we will be getting information. We will be storing information in PostgreSQL database or PostGIS with the PostGIS or MongoDB as a big database. From there, we access with the help of Jio Server and publish it and serve it with the help of leaflet in the front end or something like that, whichever is feasible for a particular project. Yeah, next. And in the key features of WebGIS, it's distributed geospatial data over the internet or an internet limited to hardwired networks. That's the main issue. We will get, even if it in a Wi-Fi, you will get stuck. You won't be having a database linkage when you move. That's where LBS got stuck up in the case of WebGIS also. But in mobile devices, if you have mobile, you need to have wireless internet all across. That is happening in the mobile platforms. That's why services can be provided at the mobile end. So LBS is not suitable again for web kind of GIS. Next. And mobile GIS, as we have been telling from the start to the end, is the technology today which gives us services with the as the technology is growing, your mobiles will be having capability of servers. As I've told in the introductory remark, we'll be having server side capable mobiles in 5 to 10 years. And not you need not go to 10 years. In 5 years time, you will be having highly compatible instruments in your hand, so that it process, and that's edge computing. That's the next technology that's coming up, is called edge computing. It's not server side computing, it's computing that comes to the edge. Your mobiles you can process a lot of information there itself and get outputs, and the servers will be loaded less. So the processed information from your edge itself is growing, giving back to the server. So the technology is growing fast, and the internet technology, once it grows, these kind of location-based services will grow very fast. Next. And that's the architecture. Next. Next. Yeah, location-based services and field-based services, two major application areas. You can take your mobile to the field, your maps to the field, your pipeline, your asset network to the field, and from the field you can make queries, you can get information, you can send information to the server that this area is damaged, it's being repaired, it's getting repaired, and the repair activity is done, and valve can be opened. All these informations and things can be automated also in this kind of technology input. You can make SCADA like applications brought in with the GIS integrated. SCADA can be brought in. Next. And mobile technology again deals with cellular phones or vehicles or anything that moves. Next. And it's integrated with wireless application protocol and Java technology. That's the two main technologies that's coming up, integrated with the wireless network. Next. And that's the architecture. I think we are moving ahead of time. Next. And it has got this kind of front ends, client side, and it has got micro services, and yeah, it has got presentation tier, web service tier, application tier, and database service tier. So and in the client side, it has got J2ME, and it's a protocol for next. It's a protocol for the micro side, and next. Yeah, client tier, web service tier, and data tier will work together to produce the mobile GIS platform. Next. and it can use a lot of field applications. And in this area, I wanted to show some examples of our applications that has been done at KSREC. That this we have been tracking all the roads with the help of LSG engineers. We have given them mobile apps, and they have been tracking entire roads of Kerala with the help of mobile apps with their attributes attached. All their attributes, their codes, their chainages, all these things are being attached with the drainage facility, the side cuts, bridges, all these informations are being junctions, all the junctions and all these LSG roads are being tracked with the help of mobile applications. And they are doing the survey. We have been technology support from our side. And next. And mobile also, all these major players are there. RGIS, AKWAO, MapInfo, Indeliware from Intergraph, Bentley, all these softwares are there in the mobile side also. Next. And some examples I thought I might have shown. Now we are now surveying the entire open wells and bore wells, all these wells, water supply locations of Kerala. Around 80 lakh of wells need to be mapped, and the groundwater department is collaborating. We are the technology provider, and they will be doing the survey from their side. And their data of wells is being collected for Kerala, and they will be knowing once the data is collected, you will be knowing per day draft of with the help of motor, or the per day how much liters of water is being pumped out from the aquifer. All these information, which are the wells that is drying up for 1 month, which are the wells drying up for 2 months, which are the wells drying up for 3 months or 6 months. All the drying wells can be identified. And we can even identify which are the upcoming wells that will be drying in the near future. So all these things, all the data is being collected. Once the data is there, it's immense value for our water resource management. Groundwater. Once the groundwater is down, you will lose your surface water also. So water resource as a whole, that data will be very hugely useful, and they are on the job. And we have done a lot of other applications like sanitation survey of rivers, lakes, and also pollution aspects, waste dumping zones. A lot of works on this educational institutions, students' facilities for online study, and a lot of other applications are there which are mobile enabled. And I think it's time, or we have lost the bus in KWA to move to the web GIS and mobile GIS platform for your work. Thank you. And if you have some questions, I can also answer.
Question ഉണ്ടെങ്കിൽ പെട്ടെന്ന് ഓരോന്നായിട്ട് ചോദിച്ചു കഴിഞ്ഞാൽ പെട്ടെന്ന് തന്നെ സാർ ആൻസർ പറഞ്ഞു.
ക്വസ്റ്റ്യൻസ് ചോദിക്കാനുള്ളവര് ഹാൻഡ് ഒന്ന് റൈസ് ചെയ്താൽ അവരെ വിളിക്കാം.
I think everybody was there. No.
Yes. ഹരികുമാർ ബി ചോദിക്കാം. Not clear. Hello.
Yeah, voice is not clear.
No, not clear. ചെറുതായിട്ട് കേൾക്കുന്നേ ഉള്ളൂ.
ഹലോ, ഇപ്പൊ കേൾക്കാമോ?
കേൾക്കാം.
സാറേ, നമ്മുടെ 2014-15 പീരീഡില് നമ്മുടെ വാട്ടർ അതോറിറ്റി ട്രിവാൻഡ്രം ഒരു പൈലറ്റ് സ്റ്റഡി നടത്തിയായിരുന്നു. I think Suresh Francis sir will be, I think Suresh Francis sir was the team leader.
Yeah.
But the, regarding the data collection and the output submitted by KSREC, the final output is a big zero. But even after 60 years of long time, the data were not yet converted to GS, and that is not in tally with the ground reality. And I think 80 lakhs of payment had already been made during 2015.
Shall I reply?
Yes, sir.
Yeah, it was a project done on a different platform. That is, it is done in 2014-15, where the mapping was done with the help of the information supplied by KWA.
Yes, sir.
Whatever map lines, pipelines, valves, pump houses, all of these informations were drawn in the road map supplied by KSREC. And whatever is drawn, we have converted into the GIS platform, and the data is available. And only thing is that, and all these data, as far as I know, and yesterday and day before yesterday also, there was data checking, and they have already, KWA has given it to external agency for evaluation. And from the external agency, I got the information that our data was good. And whatever information supplied by us to us, we have given it in the GIS platform, and the data is available. And you need to update it now with the ground reality, because it's 6-7 years. And all these updations was not done, and it was on a desktop basis again. It was on a desktop GIS, and data is on a desktop phase. You need to bring it into a web GIS platform or a mobile GIS platform, so that the data collection will be more accurate, more informative, more retrieval facilities will be there, and more analytical capabilities will be there for the user. In desktop side, analytical capabilities are there for the user at the desktop alone. But if it is converted into the server side and it's being supplied in the mobile platform, it's everybody can use. All the KWA staff can use when they are in the field, and that has not been taken up. I might have even shown Neyatingara. We have tried some work of converting the pipelines that has been collected that time, and we have brought it in the WebGIS platform. And you can see, you might have seen the Neyatingara pipeline, municipality pipeline, valves and all thing in the web for platform. I might have shown it now, but unfortunately, it's my things are not working. Anyway, but it's not the fault of KSREC. It's the support that we need from KWA was not there. Okay. It's not just arguing, and it's not a platform to do that also. But as you have told like that, I was forced to tell it like that. That's all. Since now only I think they have developed a team for GIS. One consultant was taken. And for that purpose, I was there in the interview board. And one man, Mr. Vinod, is there, and they are evaluating the data again. And the checking is now presently again going on with the consultant. Things are happening, but things are happening delayed. That's all.
Sir, it's a long period of 60 years, and we are remitted 80 lakhs in advance during 2015, I think. But
we have already supplied all the data during the project.
Furnished by data furnished by KWA to KSREC, simply scanned and converted to GIS file. That's all.
Yeah.
For that, for that simple assignment, we are remitted 80 lakhs 6 years back.
It's not that simple assignment. It's
No,
only
sir. It's a use of the software. We have purchased the 3 copies.
Hari, you can discuss in a separate platform. Actually, now
Okay,
we
sir,
are
sorry.
management is
Sorry.
dealing
No,
with.
let me clarify that
sir.
in a minute. We have
Okay.
it is only 2 layers that you have been telling. We have provided more than 10 layers. 10 layers of
Okay.
information.
One superintendent engineer Muvatupura Idiki has raised the hand. Please ask question.
Sir, I am Anil Kumar here. You are associated with KWA many times, and among the various organizations in Kerala, how do you rate KWA in applying the immense power of GIS? Whether our response is positive or not? How do you rate?
Yeah, KWA, that's what this discussion, earlier discussion was, because if KWA was proactive and was interested, we might have converted all the database into a web platform by now. Database, so that you may be knowing where to update, what to update, when to update, and updations can be done on the web itself with the help of mobile apps, and even household connections can be marked, uploaded, and all these things can be uploaded with the help of mobiles. And that didn't happen. The database developed is still lying, and it can't be used because it's not converted to the GIS or web mobile platforms.
One more question I have. Can you suggest a few areas where KWA can utilize this GIS in a better way? A few areas.
Yeah.
Activities.
Yes, the first thing itself is asset mapping. And asset mapping, I think, already have been completed, and the database things are being updation, and other things are left. In other area is the identification of water resources. Water resource for supply areas, watershed-based analysis. Third is the identification of vulnerable groundwater zones. Potential, that means vulnerability, wherever vulnerability is more, you may be able to plan your supply schemes. So prioritization of supply schemes can be done. And any activity, now location-based information is needed. So whatever you want to do, there is a component that the GIS can act.
Luna Nair raised the hand.
Yes, sir.
Please ask.
Yeah.
Explanations on the topic was very nice. It was in depth. But I have a. This is an in-depth study. Another question.
Please repeat. A small disturbance.
Okay. Sir, very good. It was in-depth study. What I want to know, actually, Anil sir has asked. Second question was, but what wells and whether the wells are dried up or whether it's filled, and all those data also we can analyze. So in that context, as far as KWA people are concerned, to know, like, regarding our pipeline, any loss or leakages, can that also be? Yes. Since GIS is mapping everything, is there a way, or I'm just asking, it's a doubt. And secondly, can the engineer site use this technology in a simplified way in their day-to-day activities? So for that, this GIS, is it helpful, or which software is to be used?
Yeah,
So was it audible?
Yeah, it was. Yeah, first question is that about the drying wells, isn't it?
Yes, drying wells and all, you are able to assess it. So similarly, KWA people, like, can we have an idea about the water table or something like that regarding the
Surely, once the data comes up, their survey they have initiated, and once the data comes up, you will be having information of all the wells of Kerala, open wells and bore wells, so that all the water level, their minimum water level, maximum water level, groundwater fluctuation, all these things will be collected along with the drying and pumping quantity. All these information are being collected. Once this data is available across Kerala, you will have that information from groundwater, because they will be government body. They can supply you the information, or you can access the web service which is being provided, so that anybody can, I think, the whatever they feel right to supply can be supplied. Otherwise, KWA being and groundwater, both underwater resources, can share information, no issues. Second question was field staff can surely use this. Field staff can use mobile applications for uploading information like pipes which are leaking. All these, whatever works that you are doing on the ground can be uploaded with the help of photos, so that it is time stamped. Anybody who is using the mobile, all these informations will get to the server. So time and person who are uploading the information and the mobile details, everything is getting uploaded. So you will be able to identify the pipes which are more getting damaged in frequently, and which are the pipes to be replaced. All these and which are the activities presently going on. All these things can be uploaded and analyzed.
Okay, thank you, sir, for the enlightening class, sir.
Thank you.
Next, Renju Mohan has raised his hand.
Sir, I'm Jio Mohan, assistant engineer, PPD Sewerage, Malappuram. Sir, actually we are extensively using QGIS software for our water supply and sewerage design application. So we are using ISRO Bhuvan's 30-meter resolution digital elevation model for our analysis purpose. So we are in a requirement of high resolution digital elevation model. So can you suggest from where we can purchase a high resolution digital elevation model? And another thing is, what is the pricing and all? Is it affordable to us? That is information that I want to know.
The digital elevation models, 30 meter is free, but it
Yes,
depends
sir,
on which resolution you require. Presently, it's available up to 0.5 meter. That means 50 centimeter. 50
Sir,
centimeter. It can be purchased through NRC. No. It's highly restricted information. You can purchase it through NRC, and it's American data, which costs around $25 to $30 square kilometer.
$25 to $30 per square kilometer.
Yeah.
Sir, how much resolution, sir?
50 centimeter.
50 centimeter. Okay, sir. Thank you so much, sir. Thank you so much for the nice question.
Raise the hand, please. Shaiju Tarathal.
Sir, just am I audible?
Yeah.
Sir, this I want to just add to what Luna has asked. Actually, I think she was asking about getting the data simultaneously from a network, pipeline network, like cities like Kochi, Calicut. For a busy city like Kochi, we have kilometers of pipelines, nearly 1,700 pipelines, and many major pipelines carrying water to the city. So it's a big problem to identify the flow. Flow to particular side. Many branches are there. At the same time, you have to identify the pressure, variation of pressure, losses, and all those things. So now I think we have already mapped all the pipelines in Gis Platform, and within a short while we are going to install some sensors to some identified control points where we can continuously monitor the variations of pressure and flow. So is it possible, or I think using the WebGIS, I think it's possible to upload the data in a real-time fashion to the GS platform in a dashboard while sitting in our office room in a dashboard or a electronic screen. We can view all the sensors data, the sensors in a canvas, so that sometimes the pressure at Alva is drops. What happened to the other Charanallur or in a particular pipeline, if the pressure increases abnormally, what will happen to other area like Pachalam, like that, and Western Kochi, what will happen? So otherwise, we'll have to ask the people through telephone or a lot of the flood of WhatsApp messages. So nowadays, to avoid all this communication, a better smart network. We are slowly switching over to a smart network. So what is the versatility, or how we can make use of the WebGS platform to that? So we need a map also at the backdrop. Also using any server, or is it possible for us to do that in a real time? I think otherwise we'll be in a big trouble in future also. So that's my question.
Yeah, are your sensors IoT enabled?
Yes, IoT enabled sensors.
So then it's very much possible. Whatever your requirements is very much possible, because it directly streams information to the net. So it should be assimilated on the server, and analysis as per your requirement need to be done, and information should be fetched back. That's all.
So how will you use the map? Do we need some rendered or hiring of the information, the map information, using some external clouds, or is there any recognized agencies supplying to a government department for that?
Already the mapping is done, pipeline mapping is done, and all these servers need to be located. As it is IoT enabled, its location will be automatically given. So you need to integrate all your flow and all other things. Presently, asset only is map. Flow direction and all other things need to be. There are two types of information. In the case of navigation, you need to have networked data of roads. Otherwise, for other analysis, for integrated analysis or overlay analysis, you do not need network database. So there are network database and normal spatial database. So in the case of pipeline also, you need to have networked database for identifying your flow direction and all other things. Which direction, from which pipe is going to the right, which pipe is going down, so that the water will automatically flow in that direction. All these flow direction and the direction of pipes need to be identified. So converting the database, existing database, into a network database need to be done, uploaded to the server. All these additional informations like sensors and information collected from the sensor to be integrated, and analysis and algorithms should be built in, so that you get your information as a decision support system.
Yes, sir. Yes, sir. I actually that physical mapping has already been done, and now the flow tracking, what you already said, the flow directions are being done right now. Then I think after this process, it will be we'll be in a position to get we'll be in a position to get the informed decision. So you can take a smart decision based on the feedback from the GS, right?
Sure.
Thank you, sir.
Okay, I think we may now stop. If any more question is there, please raise hand. I think we may conclude the session. Sri Renchu, please conclude with your remarks. Sri Renchu Mo.
Yes, sir. Sir, it was a nice section. Actually, we have started using GIS from past 2 years, and we are extensively using nowadays for our water supply and sewerage application. The class from you was it's really help us, because we are not much aware about the WebGIS platform, but actually it is that work is going on in KWA, but we are not aware about that. So we are extensively using QGIS for our application, but a lot of new information was gathered from this class, and it was really helpful for us. And we are more eager to learn a lot from your side. I think this kind of class will be very much useful for all our engineers. And thank you so much for the nice session. Thank you so much for AKWAO Tech for arranging this particular session. Thank you.
So we will make a further session from